In example 1c, the equation we're trying to solve is the natural log of x plus 1 minus the natural log of x is equal to 2. Okay, so again, the first thing you're going to want to do is recognize this as a logarithmic equation. Okay, there's an equal sign, so it makes sense to solve for x, and we've got logarithms. Okay, notice we have two logarithms of the same base on the left side of the equation. The right side is just a number. Okay, so if we condense the logarithms on the left side, then we'll be able to write this equation in the format 1 logarithm is equal to a number. And then once it's written that way, we can do the arrow thing. Okay. All right, so let's concentrate on trying to condense the logarithms on the left side. Okay, we have a logarithm minus a logarithm. Okay, so back on page 1, I jotted down those three major properties of logarithms that I was talking about that we learned in the last section. So since we're subtracting the logarithms here, okay, that's this property right here, you can combine them into one logarithm through division. Okay, so subtraction turns into division. Okay, so if we go back over here to combine these two guys, it will still be a natural log. Okay, so subtraction turns into division. The first thing will be the numerator, so x plus 1. The bottom thing, the denominator, will be the second piece here, so x. Okay, so this whole thing, the natural log of x plus 1 minus the natural log of x, has turned into 1 natural log of x plus 1 over x. Okay, that needs to equal 2. We haven't done anything to change the right side. Okay, now that it's in this format, 1 logarithm is equal to a number. We can apply the arrow method here. Okay, so this is saying, remember, since it's natural log, the base is e, so I'm just going to write that in if you need to. You don't have to, but if you need to, write it in. So if we do the arrow thing, that means if we take the base e, okay, and raise it to the second power, okay, we're going to get this quantity right here. Okay, x plus 1 over x. Okay, so the logarithm is gone. All the logarithms are gone. Okay, so now we just need to solve this for. All right, so this looks kind of complicated to solve for x. So let's talk about how you would do this. Notice e squared, e is a number. So like the left side of the equation is just a number. It's like about 7.38. Okay, don't see that square and think this is a quadratic function because it's not. The square is on the e, not on the x. Okay, this is a rational equation. Okay, so we're going to have to really think and get creative about how we solve this. Okay, it's not as easy as just isolating x. Can't use a quadratic formula. Okay, so let's talk about how we would do this. Okay, we don't like fractions. Okay, so let's get rid of the fraction. Okay, watch this. Okay, I am going to, so let me go ahead and rewrite this. Let me just rewrite this. So what I'm going to do to eliminate the fraction, since I have an x in the denominator, I'm going to multiply by x. Okay, because if I have 1 in the top and 1 in the bottom, then they'll end up canceling. Okay, but if I multiply the right side by x, that means I need to multiply the left side by x. Whatever you do to one side, you have to do to the other. So this is going to tell us that x times e squared is equal to x plus 1. Okay, because again, this x will cancel with this one. Okay, so then what? Okay, I'm trying to solve for x. Okay, so what I have here, this piece has an x. This piece has an x. So let's put everything with an x on one side. Okay, so if I come up here, okay, I'm starting with x times e squared is equal to x plus 1. I'm going to move this x over. Okay, so I'm going to subtract x from both sides. Okay, that's going to tell me that x times e squared minus x is equal to 1. Okay, now both pieces on, everything with an x is on the left. Okay, everything without an x is on the right. So x, what I'm going to do, since it belongs to both pieces on the left, I'm going to factor out an x. Okay, that's going to leave me with e squared minus 1. Okay, because if you check yourself, this is going to be x times e squared minus 1 times x, which is this, okay? So I just factored out an x, okay? What's in parentheses, well, hang on a second. Don't forget the equals 1. Okay, so now what's in parentheses, e squared minus 1, that's just a number because e is just a number. So you've got x times a number. So to solve for x, all you have to do is divide off this number. Okay, so then on the left side, this will cancel with this. So x is going to be equal to 1 over e squared minus 1. Okay, this is the exact answer. Okay, it's not a decimal. It's a funny looking answer, but this is the answer. Okay, so in the directions we were asked to give the exact answer, which is this. And then we were also asked to give a decimal approximation. So I'm going to pop this into the calculator to get an idea as to what x is. All right, so if I go to my calculator, okay, I'm going to do 1 divided by, I'm going to put the entire denominator in parentheses just to be careful. Okay, you actually need to on an older calculator. So I'm going to get e, do second ln, and it'll let you raise e to a power. So I'm going to do e squared minus 1. Okay, so this is what it should look like. Entire denominator needs to be in parentheses. So here's your decimal approximation. It's going to be about 0.157. Okay, so this is approximately 0.157. Okay, and I'll go ahead and box that as well. Okay, so we've got an exact answer, and then we've got the decimal approximation for this particular equation. Okay. So as far as, remember, you're supposed to check yourself because this is a logarithmic equation, okay? You know, with these crazy answers, I wouldn't worry about it. But remember, x is about 0.157. So if you did plug it in, you'd be taking the logarithm of something positive. And then here, if you plugged it in, you'd be taking the logarithm of something positive, okay? So, you know, you can kind of eyeball it. It is going to be okay. It does work out, okay? All right, let's jump to part D here. Okay, so now we've got log base 4 of x squared minus 9 minus log base 4 of x plus 3 is equal to 3. Okay, again, we have two logarithms of the same base on the left side. Okay, the right side is just a number. So if we condense the logarithms on the left side, then we're going to be able to write our equation in the format 1 logarithm is equal to a number. Then we can do the arrow thing. Okay, so let's start by condensing the logarithms on the left side. Okay, so here we go. We've got log base 4. Okay, it will stay base 4. Okay, we're subtracting the two logarithms just like we were doing in part C. So we know subtraction turns into division. Okay, so this is going to be log base 4 of the first quantity, that's going to go in the numerator, x squared minus 9, divided by the second quantity here. So the denominator here will be x plus 3. Okay, so again, subtraction turns into division. Okay, we've combined the logarithms into 1 base 4 logarithm. Okay, the right side is still going to equal 3. Okay, so now that we have 1 logarithm is equal to a number, we can do the arrow thing. So if we take the base and raise it to this power, so if we do 4 to the 3rd power, that's going to equal this quantity right here. Okay, so 4 cubed is going to equal x squared minus 9 over x plus 3. Okay, so if I simplify this out, 4 cubed is 4 times 4 times 4, so that's going to be 64, is equal to x squared minus 9 over x plus 3. All right, so we've got to solve this. Okay, we've gotten rid of the logarithms. Okay, we've got to figure out how to solve this equation. Okay, there's no logarithm. It's not exponential. X is not in the power. You see an x squared, so you might think quadratic, but the problem here is that this is a fraction. Okay, so you might be thinking, okay, this is complicated, and you might also be thinking to do what we did in part C, where you multiplied both sides by the denominator, which you can do, but there's a little trick to this one, okay? If you notice the numerator here factors. X squared minus 9 is going to factor into x plus 3, x minus 3. Okay, and you can check that if you multiply it back out. You're going to get x squared minus 9. The bottom is x plus 3. So what happens here is you have an x plus 3 in the top and 1 in the bottom, and they're going to cancel. Okay, so you get left with 64 equals x minus 3. Okay, and then that's really easy to solve for x. We just need to add 3 to both sides. Okay, so we're going to get that our answer here, the x value that makes this a true statement, is 67. Okay, that's the value of x that's going to make this equation a true statement. Okay, and that's it. So there was a little trick to that one. Okay, if you went back and popped in x equals 67 into the original equation, okay, again, we're just scanning it. 67 squared minus 9 is going to be a positive number. You're taking the logarithm of a positive number. And then over here, 67 plus 3 is 70. You can take the log of 70 because it's a positive number. So you're okay. This is going to be an actual solution. Okay, that's it. So just remember this method. If you are able to condense your logarithms into one so that you end up with the logarithm of the logarithm equals a number, then you're able to just apply the arrow method and go from there. Okay, so now we're going to look at the other logarithmic situation. Okay, where you're going to be able to have, you're going to be able to write your equation as one logarithm equal to one logarithm, and they're both the same base. We're going to talk about how you would solve equations that look like that.